There. On this experiment I want to show you how you can display a 10 GHz signal into a 564 Tektronix storage oscilloscope with two plugins, time base and a vertical amplifier that are capable to display only a 10 MHz signal or so. And I have tested it with another plugin I have here, which can trigger only to 2 to 3 MHz, and it works as well. So if you have a low bandwidth, nice vintage oscilloscope like this, you can certainly use it without any sampling plugins, expensive sampling plugins to do the work, the job. And the trick I have used is actually connecting the vertical amplifier to this setup here. And this setup here is an HP 5245L electronic counter, frequency counter, and it has the plugin, the 5257A transfer oscillator plugin. Now we don't have, I have not set up yet this plugin to count the actual frequency of the signal. It can be done using these thumbnail switches here in a procedure described in the manual. However, you don't need to set these switches if you don't need to count the actual signal frequency. So the only thing I did was actually having here a 10 GHz VCO set on a fixed frequency, no tuning voltage here, and it's around the X-band frequency, so around 10 GHz, and through a variable attenuator I have connected this VCO to the input of the 5257A transfer oscillator. And the trick now is to take the pulsed RF out and connect it with a cable that's a low frequency signal connected to the vertical amplifier of your oscilloscope. And voila, here is the example, the signal. So we set this, of course, for the 4 to 18 gigahertz region if we are to test a 10 gigahertz oscillator, and make sure you set this to pulsed RF. And the level has to be somewhere around here, not too low. It's a little bit tricky to set, but eventually you are going to set it correctly. And of course take the correct harmonic on this multi-turn knob. Now it's perfectly usable, and you don't have, of course, the calibration now here in the levels, but it's perfectly usable to see your signal and see if it's a distorted signal or a clean sine wave like this. Now you will notice a little bit of jitter, and I think that's normal. And I have also noticed that it's better to set this knob here a little bit off, okay, a little bit off, so the level, don't set the maximum level here, just back it up a little bit. I'm gonna do this now, back it up a little bit, and this backing up causes the frequency of the signal to, the sine wave to shrink a bit. And you can then use your time-based frequency to adjust how much do you want the signal to be expanded. Okay, that works better. And notice what it will happen if I'll try to set this signal here to the maximum level exactly, and you're going to see the signal to be expanded. Yes, as you go towards the maximum, but also you're going to see more jitter here and the frequency to be a little bit swinging. So I always prefer with this method, you see, as I set it close to the maximum point here, the jitter is much more. So I back it up a little bit. Maybe here. Okay, and you can see also the level drops. So I back it up a little bit, and let's focus here. Come on, focus. Okay, the phone doesn't want to focus now, but anyway, I back it up a little bit, and the signal is much more clear now. Okay, so this is what I wanted to show you: a 10 gigahertz signal displayed on a very low bandwidth vacuum tube oscilloscope with the help of this external sampling transfer oscillator. So, thanks very much for watching.